Nuclear power stations like the one here at Torness are generally built by the sea because they require such large amounts of cooling water. Here's the outfall to Torness, and in fact this station requires about 40 cubic metres a second of cooling water in order to operate. Including the Isles, Scotland has over 10,000 kilometres of coastline, more than either England or Wales. And this is central to the Scottish Government's drive for producing more of its energy from sustainable sources. I'll take you now over to see Professor Ian Bryden from the University of Edinburgh, who will tell you more about some of the things that are going on in Scotland in this area.
Nature has been very good to Scotland. Our west coast is exposed to very energetic waves incident from the Atlantic Ocean. The country is also situated between two massive tidal generating systems, which results in very energetic currents in locations such as the Pentland Firth. Scotland is at the centre of a new developing marine energy industry. Here in Edinburgh, for example, we have Pelamis Wave Power, who are developing the Pelamis machine, and we have Aquamarine, who are developing the Oyster wave energy system.
My name's Deborah Smith, and I'm Marketing Coordinator at Pelamis Wave Power. I'm standing now next to one of our Pelamis P2 units, which is currently in the final stages of commissioning at our quayside here in Leith Docks in Edinburgh. The Pelamis is made up of 5 tubes, which are linked by hinged joints. It's the movement between those 5 tubes which generates electricity. Pelamis gets its name from Pelamis platurus, a species of sea snake, due to the way it moves in the water and its long, thin shape.
My name is Nick Pelosi, Senior Production Engineer at Pelamis Wave Power. Here we are inside one of the 4 power conversion modules that makes up the Pelamis Wave Energy Converter. It's inside here that the electricity is generated prior to it being fed back into the national grid via subsea electrical cable. The motion of the Pelamis is resisted by hydraulic rams, which pump high-pressure fluid into storage accumulators, which you can see here behind me. We can then release the energy in a controlled manner back through hydraulic motors, which subsequently turn electrical generators and produce electricity.
In order to achieve the maximum output from Pelamis machines, we're able to control certain parameters concerning how the machine moves in the water, and we're actually able to control that from our control room here in Edinburgh.
Computer simulations are used to predict the motions and loads of the structure, as well as to provide the power predictions for a wave farm of Pelamis machines. The computer models are verified against model-scale experimental tests and full-scale operations. This video shows a comparison with 20th scale model tests that were conducted in a wave basin in Nantes, in France.
The University of Edinburgh is presently building its new all-waters current and wave test facility. This will allow the testing of wave and tidal current energy devices singly and in rays at scales of up to 1/10. The All Waters facility will complement our existing curved wave tank. This will allow you to appreciate at least some of the principles of a large test device.
Numerous systems for getting power from water waves have been tested around the world. One of the most interesting of these is the one which has been set up in Halmstad in Denmark. A great advantage of this is that it can be set up in the sea on the same platform as a wind turbine.
Wave energy devices, by their very nature, extract energy from the waves as they approach the coastline. This may cause changes in sediment distribution with possible ongoing effects on ecosystems. Tidal current devices, however, the principal suggested risk there is direct impact between the blades and marine mammals or diving birds. We do, however, believe that appropriate system design can minimise this risk.
I've come to the Scottish island of Islay to look at the first wave power machine which actually produced energy which was fed into the grid. It's called the Limpet, and as the name implies, it's actually built into the rocks. Limpet is an oscillating water column device. Inside this structure is a massive concrete chamber, and as the waves come in and out, the water level rises and falls within the chamber and compresses and decompresses the air above. And it's this air which activates the turbines which generate the electricity. In a minute I'll go inside and have a look at the turbines. Kevin here is the maintenance engineer for this system, and he's kindly shut off one of the turbines so we can actually see it. This, Kevin, I think is a Wells turbine, is that right?
Yep, that's correct.
And one of the fantastic features of this is that it's self-rectifying, and it actually works just as well if the flow's coming out one direction or in the other one.
Right.
Could you just show us inside?
I'll give it a wee spin.
Yeah, if you could just spin it round a bit, Kevin, then. Okay, now you can, Kevin shut this one off, but in fact there's one operating next door because there's two Wells turbines in this system, and you could hear the other one in operation. In a minute we'll go inside and have a look at that one. Come through now to see the smaller turbine. Kevin's kindly shut this one down, but the big one next door is still operating. And again, this is a Wells turbine. Could you just show us how this operates?
Yeah, I'll rotate the blades so you can see.
When most people start working on wave energy, they think about waves moving up and down. It's actually much better to use the horizontal motions. And one of the devices that's doing this is a thing called the Oyster, and it's now working. The number 2 is already in, and we're looking at designs for number 3 and number 4. And it's basically a hinge flap that moves like that, and you take the energy off with hydraulic rams. I'm interested in it because it's one of the stepping stones to the duck. The duck is really the front of the Oyster, but no back. We've avoided the loss of energy that you use for making the wave behind the Oyster. But it's a very, very good shallow water, early stage machine to build confidence. And I hope that we're going to be seeing a whole row of them quite soon. Most of the attention is going into the production of electricity, but we must remember that we have to produce liquid fuels for transport and substitutes for natural gas. So as well as making lots of electricity, we need to get the conversion to the other forms. The wind people are way ahead at the moment, thanks, I think, largely to Danish politics. We've got to catch up with waves and tidal streams. I think that in the near term, the tidal stream will be bigger and quicker, but eventually the resource from the wave power offshore will be perhaps double the tidal stream.